ready to density! I believe we're recording. So, this is a two-step problem here. We have an unknown liquid has a volume of 40 liters. Has a volume of 40 liters, so that's definitely volume. And a mass of 60 kilograms. Kilograms is definitely mass because it has grams in it. And clearly it's liquid because the volume's in liters. What would the volume of a 120 kilogram sample be? Well, that's mass because it's kilograms. And wants to know what would the volume be. This is a two-step problem. You're always going to solve for density in the first part of a two-step problem. Density equals mass over volume equals 60 kilograms over 40 liters. And, oh, that's probably 2.5 or 1.5. 1.50 kilograms per liter is the density. So now I will use this density over here when I have the mass is 120 kilogram. And I want to find the volume. So V equals, if you still like to do your density triangle, remember M is on top. Cover up V and you would say mass divided by density. So I'll put mass divided by density equals 120 kilograms divided by 1.50 kilogram per liter, and you would get an answer of, let's see, probably 80. Say it's 80. Let's see, kilograms cancels out, so it must be 80.0 liters. Looks good to me, yo. This has 3 sig figs. This had 3 sig figs. Well, this had 1, 2, 3, 4. Uh-oh. But this only had 3. So we want to round off to the one with the lower number of sig figs. And that's that one. Alright, I want to do one more up in here for you. An unknown liquid has a volume of 80 milliliters. That's clearly volume again. And a mass of 100 grams. Clearly mass again. What would the mass of a 120 milliliter, that's volume, sample be? Again, we'll find out density first. Mass over volume equals, in this case, the mass is 100 grams. Volume is 80.0 milliliters. 100 divided by 80, that is probably 1.25. Let's see, that's grams per milliliter. Now, I want to know what would the mass be. Oh, that's a little different. I want to find the mass. Mass equals, if I cover up density times volume, that's what I see. Cover up the M, dV. M equals dV equals density 1.25 grams per milliliter times volume, which is 120 milliliters. And now what would my answer be? I don't know. It's probably 25% more than that, which would be 25 plus a quarter of 25, which is like 6, so like 31.25 more. So therefore I would say it's 156.25. That's what I'm guessing it is. 1.5625 grams. But then I want to round this to the right number of sig figs. 3 there. Oh, that only has 1. So I should technically round to 1 sig fig. Well, I look at this 1, the 5 will make the 1 go up to 2. So as long as I'm kind of close on my math, 2 grams is the correct answer. A weird one that we only had 1 significant figure in this one and we only had to round to 1. But more importantly, that's how to do two-step density problems. Woohoo!